All right, so here what we're gonna do is we're gonna have that if we have a linear system and then we do any one of these three, we swap an equation with another. We swap two rows essentially. Or if we have that we rescale, that's 2. Or if we have row combination, that's 3, then the solution set is the same. That the solution set is not changed between the two systems. So the way you do this is you say let a1 1 x1 plus dot 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 going down a row column, so what is it, a1 n x sub n, and then it's a2 1 x1, right, plus dot dot dot, this is equals some d1, and then you have a 2n xn is equal to d2 dot 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 going down. Now this is some system a m 1 x1, sorry, x1 here, x1 plus dot 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 dot, and then you have a m1 a m n x sub n is equal to dn. Here's any system, right? This is a system of linear equations, and again, you want to check if you have, so let, right, s1 through sn be a solution to this system, right? So what does that mean? That we have this vector here be a solution to this entire system. It means that if I were to plug in s1 for x1, s2 for x2, s3 for x3, and then all the way down, so I plug in Sn for Xn, right? In each equation, the equation will be true, right? The left-hand side will equal D1, right? And for each equation. Now that's a solution to the system. Now I want to show that if I do any one of these three things, that this here is still a solution. And then I've shown that the solution sets will be the same. Now, let's do the first one. So the first one would be that if I have some row I, right, here's the ith row, right, is equal to d sub I, and then I have some jth row, okay, going down, I have some other jth row, now, if I swap these two, it should be clear that this is still a solution, right? So if I were to swapping, right, and I plug in S1 through Sn, then of course that's going to still be a solution to the system. So, this is fine. That one shouldn't be too difficult for us to believe in. So 1 is done. Okay, that if I were to just swap these, of course, if I plugging in S1 through Sn, what does that look like to this here? So, right, if I plug in S1 through Sn, right, A11 S1 plus dot 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 dot, right, A1 sub n Sn is equal to D1. That's all that means, right? That this is a solution, that I have it true, that this is going to be true for this equation. And if I plugged in S1 for x1 here and so forth, then this would be a true equation and so forth going down, right? If I swap these two rows, then of course, when I plug in S1 through here, that has no effect. This will still be a solution if I do a row swap. So I'm done with 1. Now let's do 2. Let's actually see 2. So to see 2, right, again, I know that this here, right, is going to be a solution. It's going to make it true when I plug in for each of these equations going down, right? Including for any row d sub I, or any row I. This is the ith row, right? If I rescale, right, I multiply by a non-zero constant. So now let's look at the changed system. the change system is going to be C times this whole thing for some C non-zero. And the argument is that this is still going to be a solution to the system. Of course, when I plug in S1 through Sn for any one of these, right, it's going to stay the same. So the only row that matters is the ith row. So we know in the ith row that I have something like this, A1, like, you know, x1, or let's just say s. Let's actually plug in the solution, s1 plus dot dot dot, a sub I comma n, s sub n must equal d sub I, right? We know that because we know that this is a solution to the original system. This is the ith row in the original system. So we know this is true. Now, if I multiply the original row by C, what do I get on both sides? I get A sub I 1 x1 plus C A sub I comma 2 x2 plus dot 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 C times A sub I comma n x sub n has to equal D sub I, C times D sub I, because I multiplied by C on both sides. C is non-zero. I could factor out the C, and I get A1, you know, x1 plus A1I2 x2 plus dot 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 A sub I comma n x sub n has to equal C comma D sub I. But if you look, this here, I plug in the solution, right? I plug in the solution into this, right? And when I plug into the solution, right, when I plug into the solution, I get C times A sub I 1 S1 plus dot 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 A sub I comma n S sub n has to equal, we don't know what it equals, question mark, right? C times D sub I. This here, we know, is D sub I from this. We know that this is a solution to the original system, so this must be, you know, this must equal D sub I, and then I get C times D sub I. And indeed, this is this solution makes this equation true when I multiplied by a non-zero constant, and now I'm done with 2. So I did 1, I did 2. Now the one that takes a little bit more work is 3. So 3, right, you have what? Let's do this on a different page. 3, again, what do you have? You want to check to see if row combination keeps the solution set the same, and this is the one that takes the longest. So you want to check row combination. Okay, that's what this is called. And the way to check row combination is to say, okay, again, you have some system, right? And you have, you know, some ith row, right? And you want to see if you do a row combination with the jth row, what happens. So what is a row combination? So here, and this is going to equal di, and then you have some other row j, and then this row has got to equal d sub j. Now, every other row stays the same except for the jth row. Okay, so I'm going to multiply the ith row by c, and then add it to the jth row, and then I'm going to keep the ith row the same. So the only thing that's actually changing is the jth row. But what am I doing to the jth row? Let's look. Let's make sure that we understand this by the idea. Where is this? Oh boy, where is this? This is right here. Okay, so what is it? An equation is replaced. So the jth equation, the jth row, right? An equation, or let's see, an equation is replaced by the sum of itself. So the jth equation plus the multiple of the ith equation, right? So in my case, right, I have that I'm changing the jth row. So I'm taking that out, and I'm adding it to C times the ith row, and then I'm putting that in for the jth row. That's how I'm changing this system. So now let's see. So now, okay, so what do? I multiply the ith row by C. C times A1, comma, this, plus dot, 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 and then C times A sub I n, comma, xn is equal to C times di. Right, I just multiplied the ith row by C, and now I add it to this row, and then I replace the whole system with, and there's many equations here, and then I replace the whole system. I replace the jth row, this whole thing, with the sum of this and the jth row. So everything's going to stay the same. The ith row will stay the same, right? The ith row will stay the same, but what changes is going to be that jth row. So how does that change? It's going to go j1 x1 plus dot 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 a sub j n x sub n plus, right, this whole thing, cai 1 x1 plus dot 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 going down c sub a n xn equals, right, so what happens to the right hand side? dj plus c di, right? This is the left hand side. And now this whole thing is the jth row, and then everything else stays the same. Even the ith row stays the same. So if it's a solution, let S1 through Sn be a solution to this entire system. If you plug in S1 through Sn into the original ith row, right, you get this. And if you plug in S1 through Sn into the jth row, you get this. Okay, then now you want to check, is this a solution to the new system? So how does the new system compare? Well, it's only the jth row that's been changed. So of course, since only the jth row has been changed, you only need to check the jth row. So is S1 through Sn a solution to this equation? And let's check. So we need it to equal dj plus c times di. So let's see if that's true. So let's see, I got this here, I plug in S1 for x. Maybe I should simplify first, right? What's the coefficient? Is the coefficient going to help me or hurt me in this? Let's see. Oh, no, it'll help me. Okay, I could simplify a little bit this equation without plugging in, but let's just plug in, and we could simplify afterward. So a sub j S1 plus dot 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 a sub j n Sn, right? Plus, okay, c a sub I 1 s sub 1 plus dot 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 c a sub j a sub I, because I'm changing I. Yeah, good. Okay, I s Sn. Right now, and I need to check to see if this equality is true for this situation. So what do I have now? I can, okay, this here, right? This we should see right here is just d sub I. Or no, this right here is d sub j, right? This is the j, this is the j's. So this right here is d sub j. And then plus, if you look, I could factor out a c here, and I get a sub I 1 s1 plus dot 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 plus a sub I n Sn, and we should see that that is just d sub I times c, and that's c times d sub I, and I've shown that this does indeed solve the jth equation after I do a row combination. So then that means that this is indeed a solution to the new system, and this now shows all three to being true, and I'm done with my theorem.